analyze energy dissipation. Already we have done analysis of culverts, then we just need to analyze culvert. So for the culvert energy dissipation, you just need to go through your HAC 14 documentation. So that will review your theory and the process to analyze your energy dissipation. Okay, let's see. We just need to analyze the estimate external energy dissipation. So there are four options. There is steam basin method or steam bed structures. Then you just need to steam basin. So there is four types of methods: VSBR type 3rd and SBR type 4 basin. We are just going to analyze SAF basin. Yes, in the rectangular. When you will select the rectangular, then you will see that perimeter will comes. So you need to provide that. As you can see, basin depth is coming 0.5 meters and basin velocity is coming at 0.20 meter. This is very high. Then you just have to define the basin width, so that value will comes automatically will comes when you select rectangular. If you are selecting flat, then you just need to provide this below what step slope is coming. Then you just think that we have 3 flat shaft, then it will this value will come. Okay, right, you can see. To see these perimeters in the drawing, so as you have open over here. Okay, this is the width of the basin, WB. This one is your WB basin with 6 meter, because we have taken three culverts to and one of each has 2 meter size, so there's 3 cells, so there will be 6 meter width. Okay, so this one is 6 meter width of the culverts, so that will be also becomes basin width. Okay, this is the basin depth. So this one is y1 is basin depth. Okay, this one, and then you will see this is the y2 basin depth. You will see y2, this one is y2 depth. That flow comes with high wave, then that will be the depth of y2 from this point to this point. Okay, then you just need to see exit width, that is exit velocity, that is total length L, as you can see is over here. Total length will be this one, this value, that is length of basin by LB over here, this. Okay, this length is LB. Okay, these are parameters you can see in your drawings, or you have to prepare the drawing as per this parameters. Number of chute blocks, as you can see, these are the chute blocks. This one is, and this one will be your buffer blocks. Okay, then you have to define the heights, block width, and short block width. As you can see, there the chute block size is same as the basin depth, 0.5 meters. So suitable will be height will be same as 0.5 meters. Okay, and that is the end seal depth. End seal depth, as you see over here, where we will just provide one boundary along this. This one is the end seal. Okay, just you need to define it. All right. If you are going to analyze steam bed level structures, there is a Riprap Basin, Contra Costa. Okay, so we are just Basin we are just going to analyze. Okay, we need to define the D50 mixture, as this note will be very helpful to understand the values. If we are going to HS divided by D50, which will be if we are getting 0.5 around 1 meter, you will see your HYDS ratio is greater than 2, that is okay, and divide D50 by E, that should be greater than 1.1 but should be less than 0.7. So as we are getting, that is okay also. Okay, so we need to see the Riprap Basin length. Okay, this is the Riprap Basin drawing. This one is Contra Costa line. Who is in April? So as you can see, this one is the Riprap profile, Riprap Basin. So your water will comes from this side and this will goes to the other side. Okay, as you can see, we are getting as an LB length, basin length 22.37 meter. That will be LB length. Okay, this is the pool length. This would be your pool length, LS. This would be the LS is the pool length, and this is the apron length 7.41 meter. That is LA. LA is the pool apron length. Okay, and this is the stone size you have to define for each one, as we are getting in this results. Okay, that is being made to be depth by E, and Riprap thickness is 1.5 meter. Riprap slope is 4 slope 2 meters. We need to provide it, right? That's it. Depth to water ratio, tailwater to depth, water depth ratio is coming 0.55 meters. Okay, tailwater depth is 0.69, around 0.7 meters. Average velocity with tailwater 1.94 meters. Critical depth is 0.58 meter. Average velocity with YC 2.3. Right? This is the energy dissipation. And you can see over here, this will be the plant view of the Riprap Basin. This is your culvert. Okay, that is passing along this way, and this is your Riprap Basin is going to this. Okay, you have to review this HAC 14 documents of. Thank you.